In this video, we are going to calculate an infinite limit. So if we have a function in the form that you see here, that f of x equals 1 over x to the n needs to be a positive integer, you will always get a vertical asymptote at x equals 0. So you would have learned that somewhere in an algebra class, but if you plugged in 0 to this function, it would be undefined at that point. So 0 then poses an issue. So let's talk about what happens if that power is an odd positive versus an even positive. If it's an odd positive, then as we approach 0 from the right, we're going to go up to positive infinity. But as we approach 0 from the left, we are going to go to negative infinity. So the limit at 0 would not exist. So you could just write DNE for does not exist. Now, if n is an even positive, as we approach 0 from the right, we would be heading to positive infinity, so this limit would be positive infinity. As we approach 0 from the left, we would be also heading to positive infinity. So that means that we can designate the limit at 0 as positive infinity. Now, taking all that into consideration, let's take a look at some examples. So we want to find each of these three limits for the function negative 2 over x cubed. Let's think about the graphs. So if that power is odd, we don't have any coefficients that have messed it up, that's just that 1 over x to the n, that function's look, here is the odd-powered function, kind of parent function you could think of. At 0, we have that asymptote. Here, we approach 0 from the right. We're going up, heading and skimming that asymptote to infinity. And here, we're heading to a height of negative infinity from the left side. Now, an even function, think of 1 over x squared, 1 over x to the fourth. When you square that negative, that's why this end ends up also going upward. So this end on the left side goes to positive infinity, as does the right side. Now, be careful. If there's a coefficient other than 1, it could affect the direction of this function. Mainly, if that coefficient is negative, it will flip that across the x-axis. So now that we've talked about those things, if we look at this particular function, let's think about where it lies. Which one of these would we consider it? So we would consider n, that odd positive category. Now, be careful though, because of this negative coefficient in front, where we would normally on the right go up and on the left go down, now that is going to flip those over because that negative coefficient will flip the function over across the x-axis. So as we go approaching 0 from the right, we're going to head now to negative infinity. As we approach 0 from the left, we are going to now go up and head to positive infinity. So as we approach 0, that limit wouldn't exist. Now, we can verify that if we knew what the graph looks like. This is the graph of the function negative 2 over x cubed. At 0, we have an asymptote. The left end is heading upward, and the right side of 0 is heading downward. So you can see that is our negative infinity answer to the first one. That is our answer, that positive infinity as we approach it from the left. And so that means we wouldn't exist for a limit at 0. Let's take a look at another one. So n is an even, so then it would fit in this category. Both ends would be going in the same direction. Now, as we approach 0 from the right and from the left, we should expect it to be going in the same direction. That 5 is not going to flip our function over, so both our left end and our right end will be heading to positive infinity. So this one says that our right side of 0 is heading to positive infinity. This one says our left side of 0 is heading to positive infinity. So then we can say that our limit at 0 is equal to positive infinity. But look at the graph to verify that. We see this is our function, 5 over x to the fourth. both the right end and the left end are indeed heading to positive infinity. Now, what happens if we change up the function a little bit? You may recall in like a pre-calculus or a college algebra course that if we have an x minus a in the function, if our a is positive, that's going to move it to the right. If our a is negative, it would look more like x plus a number when you see that. It's going to move that function to the left. Hence, that will move that vertical asymptote. This function now will not exist at a instead of 0 because we've shifted it left to right. Now, the same thing is true as we approach that a value. If it's an odd positive power on our x minus a quantity, the right side will go up to positive infinity. As we approach a, the left side will go down. So we would say that the limit as we approach a would not exist. Now, if n is an even positive, you'll notice same thing. Both of our left side and right side quantities will go up to positive infinity. So now that we've done that, let's look at an example that we've seen here. Well, first let's consider what we are going to categorize. Is it an odd positive or is it an odd even? Well, our powers of 5, that would be considered an odd positive. Now, the 2 in front will stretch it a little bit, but it will not change over these particular directions, so we don't have to worry about that. Our asymptote or our undefined value is at 2, and you'll see that's what we are taking the limit as we approach 2 from the right, from the left, and at 2. So we should expect that as we approach 2 from the right, we should go up to positive infinity. From the left, we should go down to negative infinity, which would make the limit as x approaches 2 of our function not exist. And we can verify that if we saw the graph. See the graph here, we have a vertical asymptote at 2. The right side is going upward as we approach that 2 value. The left side is going down. Let's do another one. So again, take a look at our function. We have this f of x equals negative 1 over the quantity of x plus 3 to the 4th. Negative 3 causes an issue. It would make it undefined. There is a vertical asymptote there. And we are going to be approaching negative 3 for each of these limits. Now, don't forget though, even though we do have a 4th power, that negative is going to flip what we would expect to happen. So we've got an even positive power. So it's an even positive power. We should expect that both ends go in the same direction. But that negative in front, instead of them going up to positive infinity, it's going to flip them down. So our right side, as we approach negative 3 from the right, it is going to be going down to negative infinity. As we approach negative 3 from the left, we're going down to negative infinity. So that means we can give an answer as the limit as x approaches negative 3 of our function as negative infinity. And then you should be able to see that in the graph if you have access to a way to graph it, or if you know how to graph it. You will see as we approach that vertical asymptote at negative 3, we are going down on both sides. Let's look at one last example. Now, this example doesn't really look like it fits this category, but if we take that function and we fully factor it out, so that's what I've done for you here, and if we reduce it down, we have some quantities that are going to cancel out. So x minus 1s cancel out on both the top and the bottom, leaving us with a simplified version, negative 1 over x plus 1. So now as we continue this example in that factored form, then you can see that it fits the category of this particular f of x equals 1 over x minus a to the n. So we can see that this fits the category now, this simplified version, that n is a positive odd. Now we have that vertical asymptote, that undefined value at negative 1. So as we approach -1 from the right and the left, we should expect it to go in opposite directions if it's an odd positive. Now, normally from the right, we would go to positive infinity and the left down to negative infinity. But that negative in front, remember, is going to flip that across the x-axis. So those things are going to flip as well. So as we approach -1 from the right, we should expect to go down to negative infinity. As we approach -1 from the left and take that limit, we should expect to go to positive infinity. So the limit at -1 wouldn't exist because we're going in opposite directions. We can verify that by looking at a graph. So this is the graph of this function. At -1, from the right side, we're going down. From the left side, we're going up. So we can see how this does actually fit the category that we were looking at. So this is how we calculate an infinite limit. Thank you so much for watching. Have a good day.